Hello, folks. Thanks for joining us today. We'll take a couple of minutes to let the people float in, and we'll probably start at 10:02, 10:03. One more minute and then we will start. All right. Welcome. My name is Renata Butko. I'm a head of product management for Traceable. And today I wanted to share with you guys what's new in Traceable, and then go through a quick demo of the product and show some screenshots of our newest functionality with support for GraphQL and GRPC API protocols. Some of you are probably already familiar with Traceable. I see among the participants our current customers and also folks that we already spoke to. So this might be something that you already know. Nevertheless, bear with me, and if there are any questions, please feel free to put that into the Q&A window of Zoom. I'll be happy to answer that at the end of the presentation. All right, so for those of you who are new to Traceable, we are an application security product focused specifically on cloud-native stacks. What Traceable does really differently is using distributed tracing to fully understand the context of the application. And with that, we understand the context of the user behavior in terms of user identity, the devices they're coming from, the roles and permissions. We understand the context of the API, including each of the API call with its own specification, the sequence of the API calls, which are external and which are internal. That is extremely important for detecting new emergent threats of the APIs, as well as correlating that with API behavior. And of course, we look at the data context as well, understanding what the sensitive data is, how the data flows from the edge to the backends, as well as the interaction and the processing between API and data and the services that actually process the data. So this distributed infrastructure that is continually changing, and our ability to understand the context of it and to detect the baseline of the behavior, which is normal, is what makes Traceable different and very well suited to the distributed architectures, particularly Kubernetes and containerized infrastructures. We work in diverse environments. Many of our customers deploy on AWS or GCP or other public clouds. But the important thing is a lot of these newer edge distributed applications are driven by the APIs. And these APIs are both external services delivered by the APIs, as well as external going to mobile applications or in-browser applications. But other APIs are either internal or are working with external backend services and backend resources. Salesforce can be a backend, Amazon S3 can be a backend. So protecting APIs becomes extremely important. In the Traceable architecture, we instrument the application itself to fully understand the API flow. We have agents that work with within the application code attaching to Java virtual machines. We have agents that can work within the distributed environment, instrumenting things like service mesh and working on Envoy that way. And we also have agents that hook into the application gateway, like, for example, an Nginx ingress controller. With all this data, they are collected and filtered by a traceable container that is called Traceable Collector, so that private and sensitive data can be redacted or obfuscated. And then the machine learning is applied within the Traceable SaaS service to monitor the security posture, detect anomalies on things that deviate from standard user on API behavior, and also provide forensics and investigative capabilities on the behavior side. And of course, all of that is very strictly partitioned into individual tenants for security and privacy, and fronted by a unified UI console that allows our customers to look at multiple locations, multiple applications, and multiple environments within their infrastructure. The key features of Traceable are firstly, its observability. Like I said, API-driven applications are extremely reliant on the APIs, and this is the reason why we are moving into expanding our API support as well, looking at additional protocols like GraphQL and GRPC. And here, one of the newer functionality that we just started providing is looking at the API API specifications. And of course, we derive API specification from stateless traffic. And what we show the users is actually more detailed than what you would typically see from Open API or Swagger spec. So individual parameters, for every individual parameters, what is the type of the data, what are the typical parameters of the data. And while we have also always learned it to detect the baseline of the API behavior and API spec, with our new functionality, we also show the users what we learned. So the boundaries of the API condition, whether the parameter is required, authentication on the API endpoint, what's going on As far as PII on that parameter, all of that is now shown on the user interface as well. So another feature we are introducing is the change management, ability to understand which parameters are new or which API endpoints are new, and monitor the change in the APIs for change management and governance that way. The other feature of Traceable is protection, and you might already know that we protect from typical OWASP top 10 APIs like SQL injection and XSS. But the unique feature of Traceable is that we're also able to protect against OWASP API top 10. Those are emergent threats, and we rely on our context understanding of the application and ability to parse multiple requests as a part of a single trace to understand the application logic attacks, such as authorization violation, for example, or mass assignment. And some of these attacks are actually more prominent in the newer protocols. For example, mass assignment is one of the attacks that is typically exploited against the GraphQL protocol there. And of course, we can also block malicious users, and we can do that based on the attack and not an individual request as well. So if a malicious user is executing an attack with multiple attempts and multiple security events, we can identify that, map that back to user ID, and block that user. And then last but not least, a popular feature that many of our users employ is drilling down into individual spans and traces and see how that correlates across different services within the infrastructure. In this functionality, we now also support with the GRPC and GraphQL protocols as well. Including the visualization on how these protocols are executed and how frequently they're executed for understanding the flows and the performance of these protocols. So what I want to do now is to pop into the product itself and give you a quick tour of a Traceable UI. When you first log in into Traceable, the first thing you see is a security dashboard that shows you the overall security posture of your application, including the volume of the calls that you're experiencing, how aggressive your current environment is, and also in terms of the unresolved threats, how that compares to the previous period, and assets at risk as well. From here, you can continue looking at the overview of your system, including the overall view on the security events, as well as seeing which endpoints or which services might need more attention. You can filter here by either the call volume, these of course are the more critical ones, or by how many security events have been detected on one or other API. But if you are in a hurry and you're an overloaded security professional who just needs to take action, you can go straight into an identified threat here and immediately see that this specific malicious user has been executing a kill chain with trying to bypass authorization. And there are 32 similar events here. And from here, you can elect to block this user right away. Or if you need more information, you can look into the details of the security events and then decide how to act from here. In terms of observability, we detect and show a complete map of your application, complete with the application flow, and look at all the microservices from the edge to the backend. And then for the individual API hosts, we show you the performance of each API endpoint. And as I was mentioning, in terms of the definition, we detect specification of the API complete with each parameter, identify if that parameter has sensitive data or personally identifiable data, and also for the parameter type and what type of bounds or boundaries the value of that parameter might take. So change management that I mentioned would be introduced here. And we also look at user behavior. I've mentioned that we are monitoring user behavior this way. And for these behaviors, we analyze this with machine learning and look at the clusters of user behavior here. You can see here that we show the API sequence, and you can compare a normal sequence like that to a potentially malicious sequence that is introduced. And here we're detecting something that went outside of the normal application flow, and it is highlighted in red as something that might need attention. This is done on the basis of groups of users exhibiting similar behavior. So more on the operational side, really, but helping you understand the posture of the application overall. In terms of now, let's move to more of the new features within Traceable. And now I want to focus a little bit more on the newer API protocols themselves. I'm sure many of you are familiar, but just as a recap, one of the new protocols that we support is GraphQL. The main purpose of GraphQL is to simplify and optimize data access. And this way, a single GraphQL call can access the data from multiple databases, multiple tables, and multiple resources. And in a single request, get only what the application needs, and not be exposed to the data that the application does not need. So here we see an example of a filtered data request for heroes that should include the name of the hero and what it appears in. And immediately we get back a schema of our data here with a hero having a certain number of names and also what movie series it appears in. In terms of observability and protection on GraphQL, GraphQL is an HTTP-based protocol. In this way, it's similar to REST protocol. And in that, it has certain new vulnerabilities that we have not seen on the REST side, but also it has some of the existing vulnerabilities that are similar to REST and also needs to be protected from those. So specifically for GraphQL, there are vulnerabilities in the schema disclosure. You can request, like I was showing you, a complete structure of the data, and unless it is disabled in advance, that can become a significant exposure of the internal application structure to a malicious user. GraphQL can retrieve large batches of data without necessarily the validation of whether the user that's requesting it is authorized to see this data. So a mass assignment is a known vulnerability within the GraphQL that needs to be monitored for. And then insufficient input validation, that's of course a problem for many of the APIs, but may become a bigger problem for GraphQL. And looking at the more generic vulnerabilities, authorization violation like BOLA and FABLA are still problems within the GraphQL environment as well as within the REST environment. And nobody has denied that the data injections, both SQL and non-SQL injections, still exist within the GraphQL environments, and of course you can only protect from those by introspection of the protocol and the API loads. So in terms of what it looks like within the traceable system, the interesting thing about GraphQL is most of the GraphQL interfaces go through a single endpoint, so to speak, that typically looks as a /GraphQL or something identified dash GraphQL. This doesn't make for a very easy introspection or analysis by security analysts. So what we have selected to do is filter the individual GraphQL requests based on whether it's a query or an update of individual fields that way. So you will see every query in the list of the endpoints on a GraphQL server or the service that implements a GraphQL server. Then in terms of analytics and observability, as I mentioned, we monitor every span and construct a trace that goes from the edge where typical GraphQL API is implemented, and all the way back to the data service where GraphQL is addressing multiple resources to assemble the data response that way. And we monitor and display each span along the way, and this is what you see here on the GraphQL query. Similarly and also different on the gRPC, it has also a popular new protocol, has completely different purpose compared to gRPC. RPC, remote procedure call, well known and famously used in the situations where you need high performance, low latency access. And similarly, gRPC is a newer open source, but extremely high performance framework. It is hosted by CNCF, the Cloud Native Computer Foundation, similarly to Google framework, Kubernetes framework, Istio and many other projects in the cloud native space. And gRPC essentially has become a foundation of many of the service meshes and direct service-to-service interactions, primarily because it is so high performant and low latency. There are certain features that make gRPC great. Extremely diverse language support, and gRPC is not an HTTP-based protocol, so it needs to be quite a bit more language specific that way, and it does support many of the languages and most of the environment. Its service definition is very simple, which is why it becomes so fast and low latency. It is bidirectional and streaming, and that means that establishing each of the session has extremely low overhead, and it is easy to work with in terms of tracing, and also supports loads balancing and health checking. Considering that Traceable is one of the very few solutions that supports security for the internal APIs, you can see why we decided to extend our security support to gRPC that way, since it is the protocol of choice for the microservices APIs these days. In terms of the vulnerabilities within gRPC, many of these are actually similar to the vulnerabilities seen within REST API. It is subject to all the same OWASP top 10 vulnerabilities, and particularly because it works within the perimeter between the microservices, shell injection and other remote code execution vulnerabilities become top and center in this case. But at the same time, we cannot forget again about SQL injection, non-SQL injection, and vulnerabilities of that nature in security serialization. With Traceable, you can also detect anomalies on internal gRPC interactions. And since we are able to introspect the API and understand the baseline, here we can detect anomalous types on the parameters. It's always been an enum, but now for some reason we've seen a string on that parameter. That would be an anomaly that is a potential indicator of a vulnerability. And of course, because we also detect how things are different for the individual value within the parameter. If it was supposed to usually be a positive integer, and suddenly we see a negative a real number that would represent a value out of range, and also be an anomaly detected by Traceable here. Similarly, on gRPC calls, as you can see, we are able to see individual spans and then stitch the individual spans together into a full trace. So you can see the flow of the gRPC call from the edge, and then how it interacts with multiple microservices here. So I encourage you to look at Traceable closer, especially if you are a new business and you're considering using one of those new advanced protocols. Traceable is very easy to install in your Kubernetes environment, whether it uses gRPC or not. It is conducive to cooperation between developers and security teams, and the results are always reliable. So that's my plug for Traceable. And at this point, I would like to open it up for questions. And if you guys want to contact me offline, I'm also available. This is my email on this slide. And in terms of additional information about Traceable, we continue publishing blogs about every week. There is new information about the newest things in Traceable, and generally our view on the cloud native security industry out there. So I don't see any open questions. Great. Well, stay tuned. Please sign up to Traceable newsletter. And when we have more new features, we'll definitely keep you posted on that. We expect to do this webinars on what's new in product about every 4 to 6 weeks. So I encourage you to also join us for the next one. A question? Yes, the recording will be available on the website and traceable.ai/webinars. All right, thank you for coming, and thank you for your interest in Traceable.